Hello everyone, we will start learning Minitab. Of course there are some preliminary parts. I will also provide them. This is about hypothesis testing part, okay? Since we don't have a lot of time, I might not be giving you every detail, but I'm gonna just give you the details that you really need right now. So I'm gonna talk to you about the example 7. This is a question about hypothesis testing. We are testing the mean. A bike manufacturer receives many calls per day about the assembly instructions for its popular bike. The main operator working the phone lines suggests to her boss that the true mean time between calls is 3 minutes. The backup operator disagrees and suggests the mean time is actually greater than 3 minutes. So they want to test the following. Null hypothesis is mean equals to 3. Alternative hypothesis is mean is greater than 3. In order to determine whether the mean time is 3 minutes or greater than 3 minutes, the time between phone calls is recorded for 64 calls. So we have a data set as you see on the right hand side. This is the Minitab. When you turn it up, there are this 64 data sets built up here. This data set is entered in the Minitab worksheet. You can either receive it as ready like in here, or you would have to type it. In order to type it, then you had to write the title of the data set, and then from starting one you're gonna start writing down the elements in the data set. And here, if we had entered some other data set, let's say calls yes or no. Okay, I just made it up, and the entries is just the terms yes or no. Then you would get this T saying that the data set is not a numeric one, it's a text one. Okay, so if you enter text words, then it's gonna recognize that it's a text data form. If it's all numeric like in here, it wouldn't say anything in here. Okay, so I'm gonna erase this part. This is just tell you that this happens. Another thing is about the date. You can enter the dates like 3/3/2019, 01/3/2019. As you see, it appeared here as D for C2. This tells us that the data is in date form. Okay, so I'm gonna erase that too because we are not gonna need that. This is just for you to know. Okay, so how do we solve in general? The solution of such a problem, we would find a z-test, standard test, statistic z-test, and then we would compare this with z alpha, right? And let's fix alpha to be 0.005. We would compare this value with z0.005, and then if we can also find the p-value, and then tell whether we reject or accept the hypothesis. On Minitab, how do you do? Okay, so since we have 64 data set, this is bigger than 40, so we can say that by central limit theorem, x bar is approximately normally distributed. Therefore, because of the normality condition, we know that we are going to compute the z-test, z-statistic. Okay, So what do you do on Minitab? There are steps in here. So we are going to open up stat here. So these are the menu of the in Minitab. We have file for the files. You click on open file, save project as. Okay, you can print the session even, and there are some other data set. This is about the editing, and whatever you write, you undo, redo, clear, delete, etc. For the data, we have all these information for the data. Okay, we can open up subset worksheet. We can delete rows, erase variables, etc. So this for calc menu is about the column statistics, row statistics. Okay, we can make pattern data. We can do that if we have time. We can assign random data depending on the distributions. These are the type of distributions, you know. And we can say form, for example, 100 data from Bernal trials or from Poisson, or distributed according to the chi-square. We can do that. And we have the probability distributions here as well. Sometimes we work on matrices, and you can find them here. We have stat button here. We are going to use this quite often. Basic statistics. So the hypothesis testing, we will do that from here. If it's a z statistic, we use one sample z. If it's t statistic, we are going to use one sample t. Sometimes the population could be more than one, so we can use two sample t, or we can use pair t. For the proportion, we have one proportion, two proportion that we use. For the variance tests for sample for one's population, we have one variance, two variance. There's this normality test. This helps you to determine whether your data follow a normal distribution or not. Okay, and some other forms as well. And for linear regression, we use this regression button. We can easily plot. Okay, here we will talk about that too. And Anova, for Anova, as you know, it is more than two populations. We can use it here to all these entries is for that. This is for design of experiment, control charts in statistical quality class. They are going to be used. We have X bar. Okay. And then more quality tools, reliability tools, multivariate, time series, tables, etc. There's this power and sample size also used time to time. Graphing is important, as you know. We can use, for example, scatter plot. We can find the histogram of the data. Stem and leaf, for example, probability plot. This is to check whether your data follow a particular distribution. Okay, and estimate percentiles. Okay, box plot is used also. Bar chart, pie chart, these are useful. Time series plot, these are useful for your future senior project. You can use Minitab in your senior project. And some other tools here. Okay, and you can get help by using help here. Assistant is also very useful. For example, it tells you in if you go to assistant hypothesis test, it's going to assist you what to use, when to use. Okay, so what's your objective? Compare one sample with a target, compare two samples with each other, compare more than two samples. Here it says use Anova here. If it is two samples, use this two sample t, pair t, two sample standard deviation, two sample defective chi-square test. If it is one sample, okay, then you're going to use one sample t, standard deviation, sample percentage, chi-square square thickness of feet. So it even helps you to choose. Okay. Yeah. Depending on whether your data is continuous or attributes, you're going to, and what you compare, is it mean versus target or standard deviation versus target, or if it is attribute, it's about the defectiveness, number of defectiveness. So we'll get the percentage of the defective. So this is a population P, okay, etc. So it helps you to go through. Okay? You can click on that, it's gonna explain more. Okay, so let's do this example. Let's do that. So we are going to go to stat, basic statistics, and we are going to choose one sample Z, and we are going to start entering the information here. One or more, so it's going to say one or more samples each in a column. So we have one sample in one column, so we are going to choose that. When we click on here, it's going to show our C1 column. Okay, then we are going to say, we are going to click on this, and we are going to say select. When we select, that means we are interested in finding one sample, we applying z-test to this column. Okay, so does the standard deviation, is the standard deviation known? In the question, standard deviation is known, and it's 2687. So we enter that, and then it says perform hypothesis. We said yes, perform hypothesis, and hypothesized mean is 3, as you know. And then we go to options. In options, it's gonna ask about the confidence level. Let's say it is 0.05. So we could say okay. We click OK, and then we see the results, and this is the result. And in this result, it's gonna say, for example, it's gonna give number of data sets, the mean, standard deviation, 95% confidence interval it's going to give you. Okay, and it's gonna give you the z value, p value, everything that you need for you to decide. That's all. Thank you.